Hi, this is Chris, and trying to make it so you can see my eyes here in the reflection. So, starting off a new email series here today about tropical forests, our biggest climate solution. And the first episode is on carbon, the unbeatable, unequable aspects of the carbon cycle that are embedded and reliant upon the tropical forest system. The citations supporting all of the research that's shown in this presentation are included on the maps themselves that are shown, as well as dozens of citations from my paper, The Systemic Climate Solution. And then I've brought in some very recent research in the last couple of months, primarily, about bigger understandings on the intactness of forests and their carbon cycle, and tropical forest value in particular. This project, Biointegrity, is about restoring the biosphere and looking at the value of doing that in relationship to climate change. Let's start out by talking about what everyone is really freaking out about this week, as we should be in the United States. The wildfires in California have now claimed over 60 lives. 600 people are missing or more at the moment. These are explosive fires. We've never seen anything like them. And what we know is that in the last less than 2 years, nearly 3 million acres of property, of people's lives, of wildlife, of ecosystems have been consumed by these crazy, catastrophic, unprecedented fires. This is of course, California, where life has been moist forever and ever. This is the floristic region of the United States. This is totally unprecedented. This is coming because of a shift in global atmospheric moisture flow. The moisture movement in the atmosphere around the planet has been radically disrupted, and that's resulted in drought in California, and more on that in the future. But one thing you should know about this series and about tropical forests is that tropical forests are co-determiners of how atmospheric moisture flows around our entire planet. As you can see in this little graphic on the left, there's a belt of moisture that flows across the equator and is characterized by these forests, which we have radically changed in the last 30 years or so. So the well-being of tropical forests has everything to do with your weather, whether you're in California, in the Amazon, in Saudi Arabia, etc. We're also going to talk in part 3 of this series about the positive weather implications of restoring the tropical forest system, of restoring the balanced moisture cycling that we had up until the last few decades, since this green infrastructure has been removed by humanity. Those weather implications include the potential to slow global warming radically, possibly even stop it. Our best resource for reducing global warming is in these forests. As you'll see, that should lead to reduced drought, increased moisture flow, balancing in the atmosphere. That should also help reduce extreme storms like Hurricane Harvey and Hurricane Florence and Hurricane Maria and so forth. So again, the goal here with Project Biointegrity is to restore the biosphere. And the goal of this presentation and this series is to help people understand the connection between restoring the biosphere and stabilizing our climate. This series covers 6 different areas about tropical forests and their relationship to the climate. Today we are just focusing on part 1, carbon, and one foundational point that we really need to introduce into the climate change conversation. There's 2 types of carbon. This is the big point. There's the fossil fuel carbon that we all know and we've been talking about for decades. Obviously the things that come out of the earth, that are buried in the earth, that are made of old dinosaurs that we then use as fuels for transportation and feedstocks for plastics and other things that we make. And when we burn these or allow these to be biodegrade, they release greenhouse gases into the atmosphere that are causing the global warming effect. However, there's a second type of carbon, and that's biological carbon. Biological carbon is living things, obviously. Every living thing has carbon in it. Any living thing that dies and is then dehydrated and biodegrades back into the earth and into the atmosphere is releasing carbon, and that carbon bonds with oxygen to make carbon dioxide, the leading greenhouse gas. It turns out that our biological emissions right now are around 18% of the global total. somewhere in the range of 10 to 20% per year, depending on the balance of every other piece of the puzzle. But biological emissions are substantial, and biological emissions are the most negative emissions because they destroy functionality, ecological functionality directly. And we'll talk about that some. So tropical forests are a biological carbon resource unlike any other on the planet. They are the biggest carbon sink on the planet. And so we're going to talk through 6 different aspects of what this carbon sink means and brings to us all as a carbon solution. In big picture terms, this carbon sink of the tropical forest is the foundation of the carbon cycle. It's our biggest carbon dioxide reduction resource, and it's a requirement if we're going to maintain global ecological security and keep moving forward with civilization and a livable planet. So biggest land sink, biggest carbon based land sink on our entire planet is in tropical forests. Here's one mapping from 2005. This is showing you soil and forest carbon density. As you can see, the tropical forest system matches exactly this mapping of the carbon density in soil and in vegetation. Why is it so dense? What's the story here? Well, it's really simple. These trees are taller than any other, these forests rather are taller than any other forests on the planet. They're older. They are the source of life on in our current biosphere. After the dinosaurs went extinct, these forests were the only thing that remained from that era, and life began again through these forests. So they're the most integrated, the most robust, the most mature, the most carbon dense, the tallest, et cetera, et cetera. They have all this height, and they are the most layered as well. And if you look carefully at this slide, you can see the little people down there by the base of the Statue of Liberty and get a sense of how these forests are 10 or stories tall, roughly speaking. And so each tree is holding hundreds and hundreds of tons of carbon dioxide. That's a whole lot of carbon there. Here's another mapping. This one's from 2008. And again, you see this stored carbon density is greatest in the tropical forest system. About 55% of global forest carbon is in tropical forests. So not only is this the biggest carbon sink on land, the biggest carbon storage unit we have on land on the entire planet, it's also the biggest carbon flux. I don't have a graphic for that, but suffice to say, we are cycling through the tropical forest. We're cycling about 4 times as much carbon on an annual basis just from the respiration of these ecosystems through photosynthesis. We're cycling it in that system. It's staying in that system. 4 times greater, the flux, than the entire emissions of humanity right now. We don't want to lose that flux. We don't want to disrupt that flux any more than we already have. We want to strengthen and restore that flux because it is the basis of our carbon cycle on land. Here's one more mapping. This is from 2012. This is showing stored carbon again in a little more detail. And you can see again that the densest areas are the greenest areas of the tropical forest system. So this is the foundation of Earth's biological land-based carbon is in the tropics. It's the oldest, it's the most important to the carbon flux, and it's the largest scale. It's also our biggest resource for reducing greenhouse gas emissions, these tropical forests. So here's one quick slide. We're going to get into this more next week, but this slide is just showing in productivity and diversity. And so the more life you have, sort of broad picture, the more photosynthesis and carbon storage and carbon sequestration you have. Tropical forests have the most life and the most activity. So they're the biggest reduction resource we have. And if we stop burning them up, these forest systems currently are being burned at a rate of hundreds of acres per day, hundreds to thousands of acres per day. If we stop these fire emissions from burning up this biological carbon, which according to the last UN report, the Intergovernmental Panel on Climate Change, was causing about 11% of greenhouse emissions burning up these forests at global scale. 11%. That's more than Japan or Canada. But burning up these forests, if we stop that, then we reduce greenhouse emissions on planet Earth 10 to 12%, just like that. It's done by protecting our most valuable carbon-based resource. So not only is it the foundation of the carbon cycle, it's also our best option for reducing carbon biologically, the fastest way to reduce carbon dioxide, the #1 greenhouse gas. Lastly, the same Intergovernmental Panel on Climate Change, the United Nations body, has said that forests are required to stay below 1.5 degrees Celsius. This came out just a few weeks ago. They've recently said that they haven't been paying attention to forests, but now they're saying that we need to reduce greenhouse gases roughly 50% over the next 10 years to stay below the catastrophic warming threshold of 1.5 degrees Celsius. Tropical forests have the greatest capacity to buy us time. By protecting them, obviously we reduce emissions. We can knock off a quarter of that goal just by stopping the incineration of our tropical forests. And we can also reduce emissions tremendously by regrowing the system, regrowing the biology in that system and the functionality of that system. Again, talk about that next week. The other big thing to be aware of is that a similar study, a global study, said it's now or never for forest carbon. This also came out a few weeks ago. So it's an article called "Protect the Last of the Wild." So just 100 years ago, 200 years ago, almost very little of planet Earth was being used to make food. 200 years ago, we had 1 billion people on Earth. Now we have 7.6 and counting. So we've jumped from a very small percentage of the Earth being used, Earth's lands, arable lands, to make food, to now over 77% to ranch, make livestock, and make agriculture. So we have just in the, 25 years or so, the last 25 years or so, we've destroyed an area of land-based wilderness that's larger than India, one of the largest nations in the world. Over 1.2 million square miles have been destroyed as we continue to expand in number and continue to expand our consumption. President LBJ said when he signed the U.S. Wilderness Act in 1964, if future generations are to remember us with gratitude rather than contempt, we must leave them a glimpse of the world as it was in the beginning. And we are about to exhaust that possibility. Anyway, the point is forests function best in numbers. So we are destroying them, and as we cut them down, we actually weaken their ability to manage global warming. And so our security depends on the security of these forests. The International Climate Body has said they are required to avoid the worst of global warming. We're really close to that threshold now, and other scientific bodies have said that we have to move today to do this. So that's the reason for this series. It's time to take action. So again, the carbon cycle as it relates to tropical forests, it's the foundation of the land-based carbon cycle. It's the biggest way to keep carbon dioxide out of the atmosphere and to pull carbon dioxide out of the atmosphere. And it's a requirement for global security. Ecologically speaking, civilization will fail if we continue to lose the carbon in these tropical forests. So you get the idea. These are the largest carbon dioxide sinks on the planet. Please give it up for the world's biggest carbon sink, biggest land-based carbon sink, tropical forests. And before wrap this up, I want to make one more major point, that biological carbon is a systems-based carbon. So when you rid the world of fossil fuel-based carbon emissions, that's great because you're making it's a win for keeping global warming at bay. But when you rid the world of biological-based carbons, it's a win for that whole system of biology that is using that carbon to produce life support services and coexist. When we put carbon back into the biological system, we win in multiple ways. So systems-based living carbon climate solutions, biological carbon, are the most multifaceted, as you have seen just in this presentation. And they are also the most globally, most stabilizing for a climate system, which you will see throughout the course of this series. When you reduce emissions from a coal plant, you reduce a problem. When you eliminate emissions from protecting a tropical forest, you stabilize the weather, you stabilize the temperature, you eliminate the carbon emission, and so much more. Okay, so the biggest solution that you can support right now is a project on the biointegrity website called Rungan River. It's just $2 an acre. And here's how it compares as a carbon reduction solution to carbon offsets. First and foremost, $2 an acre is not much money. I know if you're watching this video, you have $2. So please get involved. And this $2, when you deploy it to protect Rungan River, is protecting over 700 tons of stored carbon dioxide per acre. That amounts to about 1/3 of a penny per ton that you're protecting. If you do a carbon offset from a plane flight or something like that, you'll pay more like $10 to $12 per ton, and you probably won't be protecting a biological, ecological resource. You'll just be helping keep emissions out of the atmosphere. This keeps emissions out of the atmosphere and protects the resource. Here's the mapping of Rungan River, Rungan River's location in relationship to Earth's stored carbon. You can see it's the darkest part there. And this, I won't read through this slide, but these again are all the benefits from protecting biological carbon: weather, temperature, carbon cycle, heat absorption, moisture balancing, and so forth. We'll come back to this throughout this series. $25 donation here goes to rainforesttrust.org. They have a 30-year history of outstanding financial management and effectiveness. You'll receive a customized impacts report from BioIntegrity if you make a donation of $25 or more. And you will be protecting with that $25 over 9,000 tons of carbon dioxide. That's equivalent to biologically stored carbon dioxide. That's equivalent to more than 4 lifetime carbon footprints. You're also protecting the life in that system, which you can learn about at the website, and the global carbon cycle. So please act now. Please click below to donate and protect Earth's vital organs. You can reduce emissions by protecting the biosphere, where the biosphere is most productive. The most critical elements of life are in the tropical forests, which also happen to be the most carbon-rich land-based ecosystems. Protect the biological core of Earth's climate system, and we all win. It's an extremely important time. This is the final note in this presentation. This is a mapping that also came out a few weeks ago, and it's showing the changes in wilderness areas on planet Earth. So again, if you go back 200 years, basically most of this map would have been wild. Now, the only remaining wild areas in terms of a biologically productive area, large scale, is the Amazon. We've got several frozen forests and frozen areas. We've got several deserts, and we've got the Amazon. These are the last large wildernesses on land. It's critical that we act now to protect our wilderness areas, which are the life support systems of humanity. BioIntegrity is promoting globally strategic responses to climate change that protect the biosphere. We are protecting and restoring Earth's vital organs. Please visit biointegrity.com/solutions to get involved. Thanks.